Hello friends, with this video let us start the new chapter, Force and Laws of Motion. In this chapter we will learn about balanced and unbalanced forces. Then we will look at laws of motion. This includes first law of motion, second law of motion and third law of motion. We'll quickly understand the concept of inertia and mass, and in the end we'll conclude this chapter by reading the concept of conservation of momentum. Now, so as to give you a brief overview of why we are reading this chapter, it's because we encounter forces in our day-to-day life. When you pull an object or you push an object, we apply force on it. Similarly, when we drive a car, it is simply because there is a friction force acting between the tires and the road. So now, let's begin our chapter. Balanced and unbalanced forces. Balanced forces are those which do not change the state of rest or motion of an object. For example, application of equal or opposite forces and opposite forces on an object. So, this is my object A. I apply a force F in this direction and also apply a force F in this direction. Here, both the forces are equal and opposite in direction. Hence, the object A will remain at rest and it will not move. This is a case of balanced forces. Now, unbalanced forces are those which change the state of rest or motion of an object. Application of unequal forces on an object is an example. So, again, I take the body A, apply force F in this direction, and now, this time instead of applying F in this direction, I apply 2F. So, here we see one of the forces is greater than the other force. Hence, the body starts moving in this direction, that is the left direction. Hence, the body from rest it starts moving, and this is the case of unbalanced forces. Having understood what are balanced and unbalanced forces, now let's move on to first law of motion. Before understanding what is first law of motion, let's look at these three pictures given here. The figure A shows the movement of a ball down the inclined plane. In this case, its speed is increasing continuously. The second figure shows the case when the ball is moving up the inclined plane. In this case, what happens is, ball moves up with a decreasing speed, finally comes to rest, and then again moves back in the down direction. The third figure combines both of these motions. In this case, the ball is released from a certain height on first inclined plane and it encounters the second plane and moves upwards on the second one. What is seen is the ball moves up the inclined plane till it reaches the same height as that of the height of release. Now what we do is we start reducing the angle of inclination of the second inclined plane. We see is the ball travels more and more distance to reach the same height from which it was released. Now as we make the second inclined plane horizontal, the ball moves indefinitely to reach the same height. In this case, unbalanced forces on the ball are zero. Hence, it suggests that unbalanced forces is required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. Having understood that, let's see the first law of motion. The first law of motion states that an object remains in a state of rest or of a uniform motion in a straight line unless compelled to change that state by an applied force. The tendency of undisturbed object to stay at rest or to keep moving with the same velocity is called inertia. This is why the first law of motion is also known as the law of inertia. So what it means is, unless and until you apply an unbalanced force on a body moving in a straight line, it is going to maintain the same speed, or in case it is at rest, it won't start to move. Now, what is inertia? There is a resistance offered by an object to change its state of motion. If the object is at rest, it tends to remain at rest. Now, if the object is moving, it tends to keep moving. This property of object is called inertia. We can easily correlate inertia with our day-to-day life. When we are traveling in a bus and the brakes are suddenly applied, we tend to fall in the forward direction. This is because of inertia. What happens is, while moving, our body is moving at the same velocity as that of the bus. Now, as soon as the brakes are applied, our body, due to inertia, tries to maintain that speed. But as the bus stops, we fall forward. Now, I have a question for you all to ponder upon. Do all bodies have same inertia? You need to think about it. So I'll give you a hint for it. Inertia is the natural tendency of an object to resist a change in its state of motion or of rest. The mass of an object is a measure of inertia. So now you have to correlate the mass with inertia and get an answer. For a detailed hint, let's say I kick a small stone. When I kick a small stone, it goes with a very high velocity. Now, if I try to do the same thing on a big stone, instead of going at very high velocity, I hurt my own leg. So, now I have to correlate how masses are related to inertia. Having understood what the first law says, let's move on to the second law of motion. The impact produced by the objects depends on their mass and velocity. The momentum p of an object is defined as the product of its mass m and velocity v. So p is mv. Momentum has both direction and magnitude. Its direction is same as that of velocity v. Unbalanced forces produces change in momentum as the velocity of body changes. So when we apply an unbalanced force on a body, it changes its velocity and in turn it changes the momentum of the body. The second law of motion states that the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. That is, P2 minus P1 upon T is proportional to force, where P2 is the final momentum, P1 is the initial momentum, and T is the time taken in change of this momentum. Now, let us mathematically formulate second law of motion. Let's say a body A is moving with initial velocity u. A force F is applied for time t to make this velocity equal to v. So, in this case, P1 here is mu and the final momentum P2 is mv. So, putting it in this formula, so that is the second law of motion, we see is mv minus u upon t is directly proportional to F. Now, this v minus u upon t can be written as acceleration a, that is rate of change of velocity. Therefore, ma is proportional to F. Now this can be written as F equals to kma, where k is the proportionality constant. Now the value of F, m and a are chosen such that the value of k comes out to be 1. Therefore, what we obtained is force is equals to mass into acceleration. Given the acceleration of the body, we can find out what's the force acting on the body. Now let us look at a question. A constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meters per second to 7 meters per second. Find the magnitude of the applied force. Now, if the force was applied for a duration of 5 seconds, what would be the final velocity of the object? It is always advisable to depict the question in terms of pictures for better understanding. So, let us say an object A is of mass 5 kg and a force F is being acted on it for a duration of 2 seconds. Initially, the velocity of object is 3 meters per second and finally it becomes 7 meters per second. So acceleration of the body here becomes 7 minus 3 upon 2, that is 4 upon 2 equal to 2 meters per second square. Now we have been asked to calculate the magnitude of applied force. So what we learned was force equals to mass into acceleration. Mass of the body is 5 kg, so 5 into acceleration we found out equal to 2. So 2. Answer will be 10 kg meter per second square. Having found out the force, we have been asked to calculate the velocity if this force was applied for 5 seconds instead of 2 seconds. So from second law, we know that mass into, let's say, the final velocity becomes v minus the initial velocity 3 upon the time taken, that is 5 seconds, equals to the force applied equals to 10. Mass here is equal to 5 kg. So this 5 and this 5 cancels out. What we get is v minus 3 equal to 10. This implies v equals to 13 meters per second. So if this force of 10 kg meter per second square had been applied for 5 seconds instead of 2, its velocity would have increased to 13 meters per second. In the next video, we will learn about the third law of motion and also an important concept, that is conservation of momentum. Thank you.